Hello? Hello? Is it working? It's exactly 9:22 p.m. and we're in the middle of the zombie apocalypse. But don't worry, I was able to buy myself 10 minutes of time with you. Before the radio stations cut out, the Center for Disease Control sent me a mathematical function projecting the population of zombies over time. This function will be accurate for 1 year. As everyone knows, as the population of zombies increases, they become more aggressive. But as the population of zombies decreases, they become less aggressive, dormant, and therefore it's safe to go outside. Unfortunately, the CDC only sent me the mathematical function. It's our job to figure out which days the population of zombies is decreasing, and therefore it's safe to go outside. But first, we must figure out how to find the derivative at a point. Let's start out with the function y equals f of x. Beautiful function. What we need to do is find the derivative at a certain point on this graph. Don't let the word derivative fool you. It's actually just a slope at a certain point, or the instantaneous rate of a certain variable relative to another variable on a particular moment. Now, to find the derivative at a point, we must first plot a point. I'm going to plot point C with the corresponding f of c. Now, how are we going to find this exact slope at point C? Is it the tangent line? That's what it's called. So, I'm going to use the tangent line at point C. But how do I find the tangent line at point C? I think we need to plot another point. I'm going to plot point X with its corresponding f of x. This point X helps me create a segment with C. With 2 points, I can create a segment and find its slope. It closely resembles the tangent line, but it's not actually a great approximation. What if we move X closer to C? Now, that's what I'm talking about. Measure this slope. It's becoming more and more like the tangent line. Maybe we should move X closer to C again. Now, it actually is really close to resembling the tangent line. This brings us to our difference quotient, which is actually just starting out with our slope quotient. Change in y over change in x, which in our case equals f of x minus f of c all over x minus c. Now what we really want is a quotient where x is actually in the same spot of c. But that would get rid of the difference in y and the difference of x, leaving us with a slope of 0 over 0. What can we use to figure out the exact slope? We are moving x closer and closer to c, so maybe we can use a limit. That's what it's called. The limit as x approaches c, plugging in our slope quotient f of x minus f of c all over x minus c. This is our derived function. Wow! And it only took us 5 minutes. Now, once we figured out the derived function, how are we going to name this? Function. Well, a regular function is f of x. A derived function is probably something close to that. F prime of x. That represents the derived function. Or the value of the function at a given value of x, or the exact slope at a certain point. We don't have to use the word derived every time. It's just a big word. In our case, we want to find the derived function for the point C. So we want to find f prime of c, derived function at the point C, which is the derivative at the point C. Oh, that Oh, that's the same thing. Okay, we did it. It didn't take that long. Now that we understand the concept, let's look at some other notation. Limit as b approaches a, f of b minus f of a all over b minus a. This is going to be named the function f prime of a. Here, it resembles our first function pretty well, where we just replaced c with a and x with b. And we're taking the limit as b approaches a and then plugging in our slope quotient. Now, the next notation is the most common. The zombies are not going to be happy that I'm teaching you this. F prime of x equals limit as h approaches 0, f of x plus h minus f of x all over h. Very important. Wait, we added an x and an h. Oh, okay. Well, let's try to explain. So, now we have this graph right here, where we have one point x and another point which is an h distance away. So let's name it x plus h because it's an h distance away from x. Now what we really want is h to get so small so that x plus h is actually in the x place. Now, so h is going to want to approach 0, or the distance between this point and this point is going to approach 0, giving us the limit as h approaches 0, the point right here, f of x plus h, minus f of x, which is just the change in y, all over x plus h minus x, simplifying the x's, giving us h. Now, what I'm about to show you is top secret, the function that the CDC gave me. F of x equals 3 minus 4x squared. What we need to find is f prime of x. So, we're going to take our common notation, f prime of x equals limit as h approaches 0. Plugging in our regular function, f of x, 3 minus 4, and then our point x plus h squared minus 3 minus 4, x squared, the second point, all over h. Okay, and don't forget, x is the number of days into the zombie apocalypse. If you find f prime of x and solve this limit, and the response is positive, we know that the population of zombies is increasing. But if we take this derivative and we find that it's negative, the populations of zombies are decreasing, they are less aggressive, they are dormant, and it's safe to go outside. Go swimming, go shopping, whatever you want. Thank you. Good luck, and whatever you do, don't